I'm using a dataset about customer churn. It includes information like contract length, monthly bill, and internet service type. This data will help me build a model to predict which customers might cancel their service. I'll use one hot encoder to prepare my categorical data, specifically the internet_service feature. This converts text categories, DSL, fiber optic, no, into numbers that the model can understand. After one hot encoding, my internet_service feature becomes two new features, internet_service_DSL, and internet_service_fiber optic. Each is a binary value, 0 or 1. No internet service is represented when both these new features are 0. After training a logistic regression model, I get an array of numbers. These numbers are the coefficients, and they tell me how each feature affects the chance of a customer churning. The model's coefficient array is ordered like this. The order is important for interpreting the results. Let's see which statements accurately explain the meaning of these coefficients. I need to understand how each of the coefficients relates to a customer's likelihood of churning. My dataset has numerical features like contract_length and monthly_bill, and a categorical feature, internet_service. I need to handle this difference in data types for proper model training. I'm building a logistic regression model. It's a statistical method that predicts a probability of customer churn, a yes/no outcome. After one hot encoding, my data is ready to train the logistic regression model. Now I have numerical features only, making it suitable for training. I see a negative coefficient for monthly bill. That means, as the monthly bill increases, the log odds of churn decrease. In simpler terms, higher monthly bills are linked to a lower chance of customers leaving. It's important to remember we're talking about log odds, not the probability directly. This coefficient shows how the log odds of churn change for customers with fiber optic internet, compared to those with no internet service. We're keeping everything else the same here. The one hot encoder made no internet the base case. Remember, a change in log odds translates to a change in the probability of churn, but it is not a direct, linear change. If you see a positive coefficient for contract length, it only means that longer contracts relate to higher log odds of churn, not necessarily a higher probability. The relationship isn't straightforward. There's a curve involved because of the transformation from log odds to probabilities. I want to point out that this is incorrect. The coefficients don't show changes in the probability of churn directly. Instead, they show changes in the log odds. The log odds needs further transformation using the sigmoid function to get the probability. I see that this line introduces the concept of a coefficient array. This array holds the numerical values that represent the importance of each feature in predicting customer churn in the logistic regression model. Each number corresponds to a feature, contract_length, monthly_bill, internet service type, etc. This line shows the specific order of features in the coefficient array. Notice how one hot encoding has transformed the categorical variable, internet_service, into two numerical features, internet_service_DSL, and internet_service_fiber optic. The order is crucial for interpreting the coefficients correctly. This line sets up the multiple choice question. We need to determine which statements correctly explain how to interpret the values in the coefficient array from line 18. This is the first statement to consider. It's important to understand that this statement directly relates to a question involving the coefficient array and its meaning to predict customer churn using the variables present, i.e., contract length, monthly bills, and internet service type. Remember, the coefficients represent changes in log odds, not direct probabilities. I'm looking at the features used to train the model. We have numerical data on contract length and monthly bill, and a categorical feature for internet service type. This is a numerical variable representing the length of a customer's contract, for example, in months. This represents the customer's monthly bill amount, a numerical value. This categorical variable tells us what type of internet service the customer has: DSL, fiber optic, or no internet service. This is a technique I use to prepare the categorical internet_service data for my logistic regression model. It transforms the categorical values into numerical representations. Specifically, it creates new binary, 0 or 1, features for each Internet service type, like Internet_service_DSL, and Internet_service_fiber optic. After one hot encoding, this variable remains a numerical feature indicating the length of the contract. Similarly, after one hot encoding, this remains a numerical variable representing the customer's monthly bill amount. This is a new binary feature created by one hot encoding. It's 1 if the customer uses DSL internet, and 0 otherwise. Another binary feature from one hot encoding. It equals 1 if the customer has fiber optic internet, otherwise, it's 0. I'm using a logistic regression model to predict customer churn based on the features. The model gives me an array of coefficients, which are numbers that tell me how each feature influences the model's prediction of churn. These coefficients are for contract length, monthly bill, DSL internet service, and fiber optic internet service, in that order. Each coefficient represents the change in the log odds of churn associated with a 1-unit increase in the respective feature, holding all other factors constant. This shows the order of the coefficients in the array. The first number is the coefficient for contract_length, the second for monthly_bill, and so on. Pretty straightforward. The quiz problem is focused on understanding how to interpret the coefficients from a logistic regression model trained to predict customer churn, considering the impact of the one hot encoding. I'm looking at the features in your customer churn dataset. We have contractlength, which is a numerical value representing the length of a customer's contract, and monthlybill, another numerical value representing the customer's monthly bill. Finally, there's internetservice, a categorical feature representing the type of internet service a customer has, DSL, fiber optic, or no. Because internetservice is categorical, I need to convert it into a numerical representation before using it in the logistic regression model. I'll use one hot encoder to do this. This creates two new features, internetservice-DSL and internetservice-fiberoptic. A customer with no internet service will have zeros for both of these new features. I'm using a logistic regression model to predict customer churn. This is a great choice for a binary classification problem like this, predicting whether a customer will churn, leave the service, or not. Now, let's look at the coefficients from my trained logistic regression model. I want to make sure I understand what each one means. Each coefficient relates to one of the features in my model. This statement is incorrect. A positive coefficient means longer contracts are associated with higher log odds of churn, not necessarily a higher probability. Remember, the sigmoid function translates log odds to probability. That relationship isn't linear. This statement is correct. A negative coefficient for monthlybill indicates that as the monthly bill increases, the log odds of churn decrease. This translates to a lower probability of churn. This is absolutely correct, because I used one hot encoding, no internet service as the reference category. The coefficient for internetservice-fiberoptic shows how the log odds of churn change for fiber optic users compared to those with no internet service, while keeping other factors unchanged. Nope, this is incorrect. The coefficients represent the change in log odds *, not the direct change in probability, for a 1-unit change in the feature. I see 3 features in your dataset. Contract length, a number representing the duration of the contract, monthly bill, the customer's monthly payment amount, also a number, and internet service type, a category with options like DSL, fiber optic, or no internet. These features will be used to predict customer churn. These are the specific details of the 3 features. Notice that *internet_service* is categorical. It has names instead of numbers, which we'll need to handle differently than the numerical features. This is a technique I use to prepare my categorical data, like the internet service types, for a logistic regression model. It essentially converts those categories into numerical representations using binary, 0 or 1, dummy variables. Using one hot encoder on Internet Service will create two new features. Internet_service_DSL one if DSL, 0 otherwise, and Internet_service_fiber optic one if fiber optic, 0 otherwise. Customers with no internet service will have both of these new features set to 0. This is how I convert categorical data into numerical data my model can understand. Here, I'll train a logistic regression model using the prepared data with the features. The model will learn how to predict customer churn based on the input features. After training, the model produces a set of coefficients, one for each feature. These coefficients tell me how each feature influences the prediction. In your case, I see that you have the coefficients for contract_length monthly_bill internet_service_DSL and internet_service_fiber optic . Each coefficient shows the impact of that feature on the log odds of churn. Now, it's time to interpret the coefficient output from the model. This section presents a series of questions to check your understanding of what the coefficients mean. Let's see what you've learned. This statement is potentially misleading. A positive coefficient means a longer contract is associated with higher log odds of churn, not necessarily higher probability. The relationship between log odds and probability isn't linear. This statement is correct. A negative coefficient for monthly bill indicates that higher monthly bills are indeed linked to a lower log odds, and therefore, lower probability of churn. Correct. Because no internet service is the reference category, represented by zeros in both dummy variables. This coefficient shows the difference in log odds between having fiber optic internet and having no internet service, while keeping other factors steady. Incorrect. The coefficients represent changes in the log odds not the probability directly. To get the probability, I would need to apply a sigmoid function to the log odds. I'm asking you to interpret the meaning of the numbers that come out of a logistic regression model. These numbers tell us how much each feature influences the model's prediction of whether a customer will churn. Think of it like this. Each coefficient represents how much the log odds of churn changes when you increase the corresponding feature by 1 unit, keeping all other things constant. It's a bit like a mathematical dial for each feature, showing its impact on the churn prediction. Pretty cool, huh? This statement is incorrect. I can tell you that the coefficients don't directly tell you the change in the probability of churn. Instead, they give you the change in the log odds of churn. To get the probability itself, you need to use the sigmoid function, which transforms the log odds into probabilities. This statement is correct. I want you to understand that, because we've used one hot encoding, the coefficient for fiber optic tells you the difference in log odds of churn between someone with fiber optic internet and someone with no internet service at all. We're holding everything else the same for this comparison. This statement is incorrect. A positive coefficient means that longer contracts are associated with higher log odds of churn, not necessarily a higher probability. The relationship between log odds and probability isn't linear. It's a bit subtle. This statement is correct. A negative coefficient here means that as the monthly bill goes up, the log odds of churn go down. This indicates a lower probability of churn, because a higher monthly bill might mean customers are more satisfied and less likely to churn. This shows the order in which your model presents the coefficients. It tells you how it weighs each feature, which is crucial in understanding the model's decision-making process. Specifically, we have coefficients for contract length, monthly bill, and the two internet service types, which resulted from the one hot encoding of your categorical feature. These are the pieces of information your model uses to make a prediction. In this case, your model considers contract length, monthly bill, and internet service to predict if a customer will churn. We're focusing on how to understand the numerical outputs from a logistic regression model that you trained to predict customer churn. Understanding coefficients allows you to interpret your model's findings, which is very useful. This describes the kinds of data your model works with. One numerical variable, contract length, another numerical variable, monthly bill, and a categorical variable, internet service, with 3 levels. This is a pretty standard type of dataset.